Hey, this is Mr. Mulla for lesson 3.1, functions. So this is one of those lessons, people at home, you're going to want to take notes for this. This is not a difficult lesson, but there's just a lot of vocab and a lot of ways to solve these problems. So as you can see here, so the exploration, we're going to figure out what a function is with an equation, with an input-output table, with words, with a graph, and with a set of ordered pairs. So there's 5 different things to remember here. So this is one where kids are usually thankful that they get to use their notes because this is a lot to remember otherwise. So here we're going to be looking at a table, input-output table. So determine whether the relationship is a function and explain your reasoning. So a function is pretty much when x's can't repeat. And that's the only rule. And we'll kind of talk about that as we go on. So we're going to only look at the x's here for table A. It's 0, 1, 2, 3, 4. Okay, none of those x's are repeating, so kind of a weird way to say it. So no, none of the x's are repeating. So yes, it is a function. So no x's repeat. Okay, it doesn't matter that the y's are repeating. All we're looking at is the x's when we're talking about functions. All right, if we look at table B, our x's, our inputs are 8, 8, 8, 8, 8. Well, they're all repeating. So this one is no, it's not a function. All x's repeat. Okay, so kind of backwards way to say it. First one is a function because none of the x's are repeating. The second one is not a function because the x's are repeating. So there's one way that we are going to see functions. The other way, in example C here, that's called a mapping diagram. Okay, and it's kind of the same thing. So it kind of helps if you write it out. So 1 is paired with 8. 2 is paired with 9. 3 is paired with 10. And 3 is paired with 11. So kind of hard to see because some of you are only looking at this and look, the x's are just 1, 2, and 3. But if we write it out, we'll see, well, yep, x1, y8, x2, y9, x3, y10, x is 3, y is 11. But we have 2 that are repeating here. We have 3 and 3 that are repeating. So this one is not going to be a function. The 3's repeat. Okay, with a graph, we're going to do something called a vertical line test. So I'm going to take a straight line. Actually, let me just draw one because I don't know if I can move it then. So here's my straight line. Pretty good. Okay, and we're going to move that straight line across the graph. And if it touches any point more than one time, then it's not a function. So we're good right there. It's just touching the point right there at 0. Okay, good right there. We're touching the point at 1. Good right there. We're touching the 1 point that's at 2, 4. This one's good. We're touching the point that's at 3, 2. This one's good. We're touching the point that's at 4, 2. And we have a problem because I'm touching 2 points right here. Okay, so I'm touching a point at, let me circle them, 5, 4, and I'm touching a point at 5, 5. So there we have 2 x's that are repeating. There's a point at 5, 4, and there's a point at 5, 5. So it's not going to be a function. We also see it repeats here as well with 7, 5, and 7, 8. So no, it's not a function. 5's and 7's are repeating. All right. And then E and F. So these are ones that are ordered pairs. So same thing, we're just going to be looking at them there. So I got -2, -1, 0, 1, 2. It looks like all those are different. So yes, this is a function. Nothing repeats. Okay. F, I got -2, -1, -1, and I could stop right there. -1, -1. So no, this is not a function. X's are repeating. And if we want to be specific, whoops, ran out of room there. -1 is repeating, and then if I would have gone on, 0, 1, 2, so -1 is the only one that is repeating. All right, G and H are ones in words, okay? So each radio frequency X in a listening area has exactly one radio station Y. So that is true. This is a function. Okay, so think about that on your radio. Can you listen to K102 on K102.1 and like K99.4? Like, no, that doesn't exist. If you want to listen to K102, it has to be 102.9, I think it is. Not 102.8, not 102.7, not 103.0. Okay, K102 is 102.9. Can't listen to it anywhere else. So that one would be yes, it is a function. H, kind of a weird one. The same television station can be found on more than one channel Y. So this is like when I think about like football, there's usually like two football things. Or like now that we're in October with these debates, the debates can be seen on more than one TV channel. Okay, right? You can go to Fox and they're on there, CBS, ABC, all these different channels, and they could have the same kind of thing. So this one is going to be no, it's not a function, because sometimes TV shows repeat. Okay, not often, but sometimes they do. All right, here we got a couple situations when things are not going to be a function. Okay, the best way to do is just to graph it. Okay, so if I graph x equals 2, I'll tell you right now, it is a straight up and down graph that looks like that. And that pretty much breaks every rule because it's going to be touching the point. 2 is going to be a dot all the way through. So that's going to be a function, or that's not going to be a function because it keeps touching every point all the way through. Okay, y equals 2x plus 3 is just going to be a straight line, something that looks like that. Never going to touch 2 points at one time. So yes, this is a function. So hopefully those of you with like graphing calculators, or if you use Desmos, those graphing ones are a lot easier to see if they're going to be a function or not. All right, same thing here. So there's an example of our function on our graph. So there's the vertical line test that they want you to use. And really going back to this, it's kind of like these things are. So back in first grade when you did this, you're really answering what a function was back in first grade. But you probably called it like an in and out box or an in and out machine, a function machine, kind of the same thing. All right, let's look at some more examples here. They're kind of mixed up. So 1 and 2 determine if they're a function. So here we have a table, and then we have some ordered pairs. So looking at the table, I got -2, 0, 1, and -2. -2, -2 are repeating. So no, it's not a function. -2 and -2 are repeating. Here I got 0, 1, 2, 3. None of those are repeating. One's a 0, one's a 1, one's a 2, one's a 3. None of those are repeating. So yes, it is a function. All right, same thing here on 3 and 4. Determine whether it's a function or not. And I can see right here, I'm going to have 2 of them that are repeating. So if I take my vertical line test, and I move this vertical line over, and it happens to move the circle over too. And if I go here, it looks like it is touching 2 points at once. So this one is not going to be a function. Okay, now let's take that vertical line and use it for number 4. So touching 1 point, 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 touching 1 point. It touches 1 point throughout the whole time of the graph. All right, 5 and 6. So it says find the domain and range. Okay, so domain are all your possible x's. Range is all your possible y's. And we'll kind of see a difference here between these two. This is called a discrete graph, where like half isn't an option, 2.5 isn't an option, 3.5 isn't an option. So things like that. So this is called discrete. So when it's only can be whole numbers. Usually we're talking about this like when we were talking about like students, like how many students did this? Well, you can't have 3.5 students doing that. That's not possible. There's no such thing as half a person. Although like the one on the right, when it's all a straight line like that, then we talk about something being continuous, like money. We could have $3.50 or $2.50 or $2.37. Something like that can exist, like when we're talking about money. Number 5, you can't have 2.37 people. That's not possible. So when we're listing things here, so domain, we're going to list all the possible x's that there are. And so it kind of stinks. We got to write them all out. So we have 0, we have 1, we have 2, we have 3, we have 4, we have 5. So all of these dots represent a different domain. Range is a little easier because it looks like the ranges are only at 4 and at 3. And so I'm going to put them in order. I'm going to say 3 and 4. So remember, domain, all your possible x's, ranges, all your possible y's. Okay, a little different on number 6, since it could be something that's like 0.2 or 0.2234972, where you have to write all the numbers in between there. Okay, that would take us a really long time and pretty much be impossible. So instead, what we do is we're going to look at the most left point. It looks like -3. And we're going to say it's somewhere between -3, and then we're going to look at the most right point and +3. So anywhere between those two numbers is your domain. And it includes all those decimals and all that stuff, so we don't need to worry about that. So remember, domain is your x's, your furthest left point to your furthest right point. Ranges are your y's, your lowest point to your highest point. So here, our lowest point is 0. It doesn't get anywhere below 0. And then it looks like our highest point is going to be +3. Doesn't look like it gets any higher than +3. So notice how I wrote that domain with an x point and then the range with a y in the middle so that we don't get confused there. All right, last one. So the function y equals 12x represents the number of pages of text a computer printer can print in x minutes. Identify the independent and dependent variable. Okay, so remember, dependent is the things that we can control. Independent is the things we can't. So if we're telling a printer to print something, out of those two scenarios, whether it's the paper or the minutes, we can control. So it says y is going to be dependent. We can control how many pages print. If I want to print 30 pages or if I want to print 1 page, that's something we can control. We can tell the printer, print this many pages. So it is dependent on what we say. Independent is what we can't control. I can't control how long it's going to take to print out those pages. I can yell at the printer, I could tell it to hurry up, but that's not going to do anything. So I can't really say, hey, printer, hurry up, and then it's magically going to go faster, or hey, printer, slow down, you're going too fast. I can't do that. The printer's not going to listen to me. Okay? So independent is things that you can't control, in this case, time, minutes. Dependent are things that we can control, so like the number of pages. So if it says domain is 1, 2, 3, 4, what is the range? Okay, so if it can print 12 pages a minute, after 1 minute, that means it printed 12 pages. After 2 minutes, that means it printed 24 pages. After 3 minutes, 36 pages. And after 4 minutes, 48 pages. So here's our domains. Here's our ranges. Hope that helps. Have a good day.